I'm good. How are you?
Good. Alright, so let's see. You must have finals coming up, huh?
Yeah.
Got some problems you can verbalize?
What?
Do you have some problems that you can verbalize?
Oh, yeah.
Okay.
So the question is, determine which of the following formulas, or I don't know if it would be better for me to send you this one. So maybe we could do a different one, and while we're doing that one, I'll send you this.
Okay.
Okay. This one says, determine the nature of the roots of the quadratic function that has the following values in quadratic formula. And the function is -6 plus or minus 2 root 33 all over 6.
And they want us to figure out what quadratic results in that, huh?
Yeah, so we have to determine the nature of the roots and sketch a possible graph.
How many roots do we have?
2?
Are they real or imaginary?
Imaginary.
No, they're real. In other words, you only get imaginary roots when you have a square root of a negative number.
Oh. Mm-hmm.
Okay? So this would be 2 real, but also irrational. In other words, it is irrational because it's the square root of 33. But that is still real. It's not imaginary. Okay? Now, since the answer that it got what's the general formula of the quadratic?
A squared plus b.
No, it starts with minus b.
Oh, negative b plus or minus square root of b squared minus 4ac all over 2a.
So what is b of our quadratic?
6.
What is a?
3.
So the only thing we need to figure out is c. And this is a little tricky because of this 2 here. For the sake of argument, let's put that 2 back inside the radical.
Okay.
So that the radical becomes that. See what I did? Okay. So now we know that originally when we solved this, we got b squared minus 4ac was equal to this number. B squared minus 4ac must be equal to 132. And to figure that out, I had to put the 2 back inside. Because the only way you get that 2 is that if it started out as a 4 inside the radical. Right? In which case you'd be able to factor it out and pull it outside. So, all we need to do here is solve for c. We know what b and a are. So b squared is 36 minus 4 times a is 3 times c. That has to be 132. Well, let's solve that equation. We get minus 12c equals 96 minus 8.
Okay.
There's your answer. Now we have A, B, and C. So what is the function?
3x squared plus 6x minus 8.
Yeah. In other words, if we started with that function and tried to find its roots, we would plug it into this, and we would get all of the numbers you said. We would end up getting this, and so forth and so on. The only difficult thing with this problem is they force you to work backwards, which is pretty unusual. I can't say I've honestly seen that before. You think you see it all with teaching math, but every now and then somebody comes up with a problem that you haven't seen before. This is one.
Okay.
Pretty clever, actually.
The
tough part was putting this back inside and realizing why you had to do that. Because when you solve the quadratic formula, it doesn't come with a coefficient in front of that. The only way you end up with a 2 in front of the radical sign is if you had a 4 inside here that you were able to take out.
Okay. And the email should be sending.
Yeah, I think I got it.
So,
I think I got it. Hold on. No, I didn't get it yet. Okay, you want to read another one?
yes. Okay. This is a word problem.
Okay.
So, a rectangular living room with wooden floors has a rectangular carpet directly in the center of the room. The exposed wood in the room is of uniform width around the carpet. If the dimensions of the carpet are 6 by 8 feet, and there are 200 square feet of wood exposed, how wide is the uniform wooden border around the carpet?
Okay. The one piece of information they've given us is that this thickness from here to here is the same as from here to here.
Okay.
So let's put a variable on that. What shall we call it?
X.
Okay? Now, we can say, if we want, a shaded area problem. If I said to you, what is the area of the shaded region, you would say what?
200 minus 48.
Not quite. It would be the area of the large rectangle minus the area of the small rectangle.
Okay.
It's not 200. 200 is not the area of the large rectangle. If that were true, you would be absolutely right. But the shaded area, the shaded area here is the wooded area. That's the area that's all wood paneling. Everywhere where I got a little squiggly mark here is wood, and here is rug. Okay, so that's rug. This is wood. But in general, when you look at shaded area problems, the shaded area is equal to the area of the large minus the area of the small. With our variables, what is the area of the large rectangle?
248.
No, as a function of x. Well, okay. No, I see what you did. I see what you did. Okay. You still need a formula for the area of the large rectangle. what is the formula for the area of the large rectangle based on what you see in this picture? This is x over here. That's x there. That's x there. That's x here. That's x here. That's x here.
Okay. So 8 plus 2x times 6 plus 2x?
That is the area of the large rectangle. The area of the small rectangle is 48. So the wooded area is equal to the area of the large rectangle minus the area of the small rectangle, and that's equal to 200. In other words, the equation I can write is 200 is equal to 8 plus 2x times 6 plus 2x minus 48.
Okay.
So now we have to solve that equation for x in order to figure out what the area of the large rectangle is.
Okay.
You're right that it's 248, but they don't really want the area of the large rectangle. They want the dimension of the distance between, you know, in other words, they want this. They want to know this distance, x. So let's solve it.
Okay. So if you multiply those two together, you get 4x squared plus 28x plus 48 minus 48. So then the 48 would cancel out.
Okay. So now what?
So now subtract the 200?
Yeah. Now what?
Great. You could find a greatest common factor.
What is it?
4.
Okay.
So x squared plus 7x minus 50. And then
I don't think this factors nicely, does it?
I don't think so.
So you have to use the quadratic.
Okay. So A equals 1, B equals 7, C equals negative 50.
Okay.
So negative 7 plus or minus the square root of 49 minus 4 times minus 200 all over 2.
Okay, you got to be careful that you don't get the sign wrong here. It's b squared minus 4ac.
Oh, plus 200. So 249.
So what is this distance right here?
-7 plus or minus the square root of 249 over 2.
If you take the minus part of that, you're going to have a negative number.
Mm-hmm.
So you can throw out this solution.
Okay.
Because whenever you're figuring out dimension, you can't have a negative dimension.
Yeah.
So the answer is -7 plus square root of 249 divided by 2. That is x.
Okay.
Okay? And you could actually give the answer like that. That's actually a better answer than if you convert this to some decimal that's going to be an approximation and go from there. But it looks to be about 11. I don't know. The square root of that is 15 and change. So it would be 8 over 4, 2, 4. This looks to be about 4 and change. 4 plus.
It is 4.38.
Okay. Shaded region problems. In other words, every time you see a shaded region problem, it is always a subtraction problem.
Okay.
If I say, what's this shaded region, we don't generally have the math to figure out what that area of that is. However, I can definitely figure out the area of the big circle and the little circle. So the shaded region is always the area of the big circle minus the area of the little circle, or in our case, the area of the big rectangle minus the area of the little rectangle.
Okay.
But when you see a shaded region problem, think instantly that it's a subtraction problem.
Okay.
Okay?
And then I have another word problem.
Okay. Here, let me see if that email came in. It did.
Well, I think I'd rather do this word problem than email.
Okay.
Because I don't know.
Go
I
ahead.
think this one's heavy. Okay, so it says the
Before you read the word problem to me, read the last sentence of it.
What price should the Rapids put on their season tickets to maximize their revenue? What is the maximum revenue?
Okay, now read the whole thing.
Okay, the Colorado Rapids currently have 1,200 season ticket holders who pay $120 for each season ticket.
Okay.
Due to escalating player salaries, the Rapids need to increase the price of the season tickets. For every $10 increase in price, research shows that 40 fewer tickets will be sold. What price should the Rapids put on their season tickets to maximize their revenue? What is the maximum revenue?
Okay. So, this is a bit of a difficult word problem. What is revenue going to equal?
X?
Hold on, before we even get to that, give me a word definition of revenue.
The money earned from the season tickets?
Well, it's the number of season ticket holders times the price of each ticket. Right?
Oh, okay.
In other words, currently, the revenue is $1,200 times 120, or $144,000. That's what existing revenue is. They want to boost it. Okay?
Okay.
Notice that if they change the price of the tickets to 130, now they're going to get 130, but they're going to lose 40 season ticket holders, so their revenue would be back.
Oh.
Okay? What is that number? What is 1160 times 130?
Equals 150,800.
Well, you would definitely do that, huh? If you were the Colorado Rapids, you'd rather make 150,000 than 144,000.
Yeah.
So there is some magic point. Obviously, if I were to up the price by $1,000, I would lose 4,000 customers. I wouldn't have any customers at all. I'd have zero revenue. So there is some perfect price to up the revenue by that will maximize the revenue. Well, this is going to end up being a quadratic, and any quadratic is a parabola. So to maximize any quadratic function, you find the vertex. So let's see if we can put this together as a quadratic. What should our variable be? That's why this is a little trickier than the typical word problem.
Yeah. That's why I needed help on this one. I didn't.
The variable we want to make is the number of $10 increases. We know that if x is 1, that increases revenue. That's the only thing we just showed by our calculations. If I increase the price by exactly $10, I definitely boost the revenue. Question is, how many $10 price increases should I make it? Would it be right to increase the price by $30? Well, we don't know. But we do know something. What is our revenue as a function of this price? There's the price of each ticket. Right?
Yeah.
In other words, if X represents the number of $10 price increases, and I decide to do 1, I didn't do that right. It's the new price of the ticket. Sure. Now my thing's going to go bad on me. Hold on. The new price of the ticket is going to be 120. Excuse me, I got to erase this and bring up a new one. All right. Sometimes you have to play around with this a little bit. There is the new price of a ticket. Remember, number of $10 increases. So if I do just an X of 1, well, this gives you the new ticket price, which is $130. Total revenue is the new ticket price times the number of people who have season tickets. Well, there are currently 1,200. But I know that I'm going to lose 40 for every X.
Okay.
So this is the new price. And this is the new number of season ticket holders. We started at 120 was our old price, and we had 1,200 season ticket holders. Okay. So the first thing you want to do is come up with your formula as a function of your variable. So our total revenue is going to now be this quadratic.
Okay.
Multiply these two together.
So it would be negative 400 x squared plus 120 or 12,000 x plus or minus 4,800 x plus 144,000.
Okay. Let's combine that and see if that's your total revenue. And our goal, this we can see is going to be a parabola that looks like that, right? Because it's got a negative coefficient in front of the x squared.
Mm-hmm.
So the maximum revenue comes right there. So if I can graph this function, or even if I can't graph it, is all I have to do is figure out where this is on the x-axis.
Okay.
That's actually pretty easy to do. What's the line of symmetry for a quadratic? It's the vertex.
The x.
The x
Yeah.
of the vertex. What's the formula? It's the first half of the quadratic. Minus b over 2a. You with me?
Yeah.
Kind of or totally?
Yeah, I am.
Okay.
I was just wondering, can I just like graph it since I have an equation on my calculator?
You can, yeah, sure. And then figure out where your max is.
Yeah.
Now make sure you combine these two numbers first.
Okay.
And the whole thing will be divisible by 4, but as long as you're going to do it the way you're talking about doing it, I don't know that you even need to go to that trouble. And in fact, the easiest way I see to do it is to just plug in minus b over 2a and figure out what that is.
Okay.
This comes to 7,200, I believe. X. So minus 7,200 all over minus 800 is your answer. 9. X of 9. See, I did it faster in my head using minus b over 2a than you can do on your calculator.
Yeah. So you, okay. Negative b. So,
Negative b should be minus 7,200.
Yep.
All divided by 2a, which should be minus 800.
And you get 9?
Yeah.
So that equals the axis of symmetry?
That's the axis of symmetry. It's also the x value at where you produce the maximum amount of revenue. Now, we didn't figure out what that revenue is yet, but that's easy enough to do. Go back into this formula, plug in 9 for x, and see what the new revenue is. That's probably the question B for that question. I can't imagine them asking this question without asking you, and what is that revenue?
Yeah. I got 176,400.
Okay. I'm not doing it on my calculator, but that sounds right. That's more than what they had to begin with. It's also more than what we would get if with an x of 1. So they're saying that if X is 9, the new price is $210 per ticket. And they're going to lose 360 season ticket holders. So their season ticket holders go down to 840 from 1,200. So they may be making more money, but they're going to have a smaller audience.
Okay. I see.
But that's okay. In other words, their only goal is to maximize that revenue. They'd rather have, what was it, $176,000 than $144,000. They don't care how many people are in the stands.
Yeah. Okay.
Fortunately, I have a 4 o'clock, Ellen, that I got to go to.
Okay.
So hopefully that's done you some good.
Yep, it has.
Okay. Talk to you later.